Hey, hello, my name is Fabian Deutsch. Welcome to this session. Please find a seat and I'll start my screen sharing to get started. So, hello, my name is Fabian Deutsch and I'm working for Red Hat. I'm doing this session jointly with Marcus. He will introduce himself later on. We're going to speak about using KubeVirt to run VMs at scale. Before we dive into the topic, let's set the context a little bit. Right? The future is bright, and it's even brighter with Kubernetes. Kubernetes has seen a tremendous growth, right? And we've seen so many companies and people, organizations being interested in Kubernetes for a reason, right? It's bringing value, right? There are new workflows, new concepts, new patterns, right? I think that declarative approach, new networking plugins, new alerting and monitoring tools, auditing tools, tracing tools. There's so much around Kubernetes. You see it at every real KubeCon if you go to the booth area and see how many booths are there from companies and organizations, CNCF projects, right? And I have the feeling that we're sometimes following this wave into the future, right? We're getting dragged forward in the suction of this wave. And on this slide, you actually see this wave on the right-hand side, the reddish area, right, which is the search volume for Docker. And we often actively pursue down this path. We personally, or our organization, or developers, right? And we do it for a reason, as I said, right? The newly established cloud-native patterns and workflows and technologies, actually, many of them finding new home in the CNCF, they allow us to do our work more efficiently. They bring benefits to the delivery pipeline, to the quality standards with CI/CD, right? It's a new generation of a family of tools. And the whole industry is resembling itself around this new container-based patterns and concepts. So me as an infrastructure guy, I still count myself as an infrastructure guy, I come from that area, right? I think we have to enable our developers to leverage this family of tools, right? We need to allow them to play with them, to learn them, to adopt them, to write new applications, to solve new problems more efficiently than they did it before. And as an infrastructure guy, just to get back, I think it's our responsibility. That's so exaggerating, right? We should build avenues and bridges to allow them to do that, right? We need to enable our developers to work with this family of tools and technologies. However, as an infrastructure guy, on the other hand, or as an organization, right, we see that everything we've built and maintained before just does not go away, right? A lot of the legacy we piled up in the last decade will remain. We need to continue to operate it. On this diagram, right, on the left-hand side, the blue added data points are showing the search volume around virtual machines, right? And we see a tip on the left for VMs and a tip on the right for containers, in quotes, because it was Docker. But we see the trend, right? But the blue is actually highlighting how much we've built, how much interest there was, right? And we need to maintain that. We need to find a solution what we do with this. As an infrastructure guy, right, I need to see how we're doing it, right? Because there's a benefit for running it, for operating it, right? For providing the services that the VMs are providing us today. Sometimes we can rewrite the application inside the VM to work cloud native and to run on Kubernetes, but sometimes that's not possible and feasible, for example, from a financial standpoint. And that's where KubeVirt comes in. KubeVirt is a cloud native computing foundation sandbox project. We actually entered the sandbox last year, and it's marrying virtual machines and Kubernetes, right? It's a Kubernetes add-on, right? It's an operator. It's using CRDs to extend the Kubernetes API, and it's mapping its workloads to pods. You effectively only need a single YAML line in order to install it. So how does it look technically? We've got kubectl at the top left, which you can use to interact with KubeVirt, right? It has a lot of components, and the essence is that we extend the API and we run pods for you, which act as VMs. And I would like to steer your focus to two important areas that actually show the important bits of KubeVirt. On the left-hand side, you see that circle, which is circling out the virt controller. This makes KubeVirt declarative, just like Kubernetes is, right? So you have YAMLs, you define the desired system state or the desired VM state in this case. And the controller and other controllers will make sure to get that system into that state or fail, right? So it feels like Kubernetes. The way how you interact with the system is just like Kubernetes. On the right-hand side, the second important aspect is that to kube, it's a pod, and that's fine, right? We did not want to teach Kubernetes yet another entity. Instead, we wanted to say pods remain the atomic compute unit. And that's why VMs are ultimately running inside of pods. This actually enables a few things, because first, the orchestrator can be kept simple. It doesn't need to know about two kinds. And tools that know how to monitor pods, for example, they implicitly monitor VMs. kubectl will thus be the tool of choice to rule them all, right? So I was already saying we're extending the API, and you can simply use kubectl edit, kubectl patch, kubectl create to work with VMs. Actually, live migrations, which I'll get to in a second, are handled the very same way with kubectl. There's a companion tool called virt-ctl, which provides a little bit more convenience. Like there's certain things which are not relevant for containers, like graphical desktops, and thus they're not present in kubectl. virt-ctl allows you to directly connect to the graphical desktop, but it's really the exception. virt-ctl can be installed as a plugin to kubectl, for example, using crew. So what can you manage? We've got the basics, right? Start, stop, pause, resume. Live migration might sound odd, but because, as I mentioned before, pods are like, VMs are running inside pods, consider the pod to be the context, and then the live migration is nothing else than moving the VM from one context to the new, where the context is the pod. Pods, however, cannot be live migrated, just to clarify that point. We support multi-network and actually SR-IOV network card using multus, so we're not inventing something new here. We just tied into the de facto networking standard, which multus is one implementation of. We support block and also file system storage using persistent volume, so the same mechanism. And we've got pending PRs. Maybe by now or by the time of this session, that PR is actually merged or not. But the important point here is it's mapping to the underlying infrastructure of Kubernetes again, so volume snapshots. Why is that important? Because the thing to highlight here is that the resources are not managed by Kubernetes. KubeVirt is exclusively consuming resources from Kubernetes, right? Sorry, the resources are exclusively consumed from Kubernetes. KubeVirt is not doing any management here. And that has a few benefits we'll see in a few slides. One benefit is that you develop on and only use one platform, right? So developers which want to work with either VMs or containers, they just have to know that one platform, right? There are IDEs like Che, which can run on Kubernetes. And you can just use that IDE to really work with both entities. This enables developer self-service, right? And it's actually simplifying and unifying the access to resources in general, right? With pods, you already have the abstractions like dynamic provisioning, right? Which are providing dynamic access based on the quota you have to storage, or network is transparently there. And as KubeVirt is tying to the same models, the same workflows or self-service limitations or opportunities apply to KubeVirt as well. One interesting part or use case that has emerged relevant for developers is actually kube on kube, right? KubeVirt is providing you VMs on bare metal Kubernetes clusters. And once you have those VMs and you have network and you have storage, then you can actually easily bring up a Kubernetes cluster running on Kubernetes. Actually, you can bring up multiple Kubernetes clusters running on a single shared Kubernetes cluster as the infrastructure below. And there are a couple of community projects which are focusing on this specific use case. And that actually is the segue for this slide. You only have to operate one platform. And even in the previous case, right, that there might be multiple instances of the same platform, right? You have tenant clusters using Kubernetes and the under Kubernetes cluster to host them. It still means that you've got one system you need to know, and one system you need to know inside out, right? And that's relevant because there are different parties in your company and they need to speak to each other about the system, right? Resolving problems. The developer can speak to the IT department to understand why is my storage provisioning not working, right? And there's only one system to worry about, not multiple. Important here is also to note that with KubeVirt, we're actually setting the stage for where we want to go, right? With KubeVirt, you have the opportunity to say, this is the ideal architecture I want to pursue in future, right? I would have Kubernetes at the heart and extend it to support my legacy workloads as long as I need them. Now, let's get to the heart of this session, to scale. Just a few words before I hand over to Marcus. So KubeVirt in general is adopting patterns from Kube, right? It's adopting controllers and watchers to efficiently work with or scale out to many entities. On the node level, it's actually using, as I said before, network storage and other node level features from Kubernetes and not inventing their own. So in both cases, on the cluster level, because we adopt the same patterns as Kubernetes, we assume that we're not putting an artificial or KubeVirt specific upper bound to the scale from the cluster perspective, right? Because we adopt the patterns that Kubernetes itself is using. Also in the node level, because we are exclusively leveraging Kubernetes to provide and manage the resources, there are also no limits from the Kubernetes KubeVirt perspective in the scale of how these resources can be consumed on the node level. Or in other words, there should be no KubeVirt specific limits on the node or cluster level, because we inherit most of the stuff from Kubernetes anyway. So Kubernetes is setting the scale limits. In addition, KubeVirt is cloud native, or parts of it are. It is in general, it's a cloud native application. And certain parts are scalable, right? So for example, the controller, if you want to have a higher resilience, you can scale it out. If you want to actually allow it to support more entities, like tens of thousands of VMs, then there are tunables to allow you to give it more processing power, to give it more RAM, to give it more computing threads, to deal with that large amount of entities. And with that being said, I would like to hand over to Marcus to take it from here and show it how that is looking.
Hi, my name is Marcus Sorensen, and I feel thankful and privileged to be able to speak to you today about the KubeVirt project at KubeCon EU. I want to take a minute to introduce myself. I'm coming to you today from my home in the state of Utah in the United States. I started my career working in semiconductor fabs in the on-site data centers for Intel and Micron. I was lucky enough to be able to travel across the globe and help set up new semiconductor facilities and the data centers that serve them. From there, I transitioned to public web hosting. I worked at Bluehost and Endurance International, and there I learned a lot about internet traffic, networking technologies. I learned about multi-tenancy, and I learned about how to host public services securely and how to automate customer deployments. That naturally led me to VPS, virtual private servers, and cloud technologies. I got involved with the Apache CloudStack project, and I helped them deploy new features and functionality for the KVM hypervisor. I took CloudStack and combined it with high-performance computing technologies like InfiniBand and SCSI RDMA storage to create cutting-edge, high-performance virtual private cloud platforms. And now I'm at Apple. I've been here almost 6 years, and it's always challenging, it's always rewarding, and there are always new problems to solve. And that's really what got me into KubeVirt. Now I can see that my audience is super excited to hear everything I have to say about KubeVirt. So let's go ahead and get started. I'm going to start today by talking about the things that actually attracted me to KubeVirt in the first place. What was it that interested me and got me thinking that KubeVirt was worthwhile to participate in? Then I'll talk about some of the challenges that I ran into, which ultimately led to contributions and changes to KubeVirt itself. Then we'll talk about some of the use cases that I've used KubeVirt for, and then maybe some tips and extras that I found handy when using KubeVirt. So to get started, discussing why KubeVirt. When Kubernetes started getting really popular as a data center scale cloud platform, I began to wonder, me working on virtual machines, how can I take advantage of that? How can I run the workloads that I know need to be virtual machine workloads, or things that can't easily be transferred to containers or take too much effort? How could I run the plethora of things that I know are bare metal services, that are VM services in Kubernetes? And I wanted something that didn't require modification of Kubernetes itself, didn't require a lot of low-level node configurations. And I looked at a few different competing technologies, and I came down to KubeVirt. One of the awesome things about having Kubernetes with KubeVirt installed is that you get this single pane of glass. You get one user interface for everybody to run their services, whether it's containers or virtual machines, people who just need a server or an OS. You can run Windows machines, you can run appliances, and it's all using the same tools. You can run kubectl, and you can plug into the API, and you can use all the same tooling. You have persistent volume claims and whatever you're using for ingress, and it's all kind of melded together into one cohesive service. And so those are the things that really brought me into the KubeVirt community and got me involved. Okay, so KubeVirt is amazing. It provides this nice service in your Kubernetes cluster. But there are some issues that I ran into when I was trying to use it. The first thing that comes to mind is the virt-operator deployment model. The virt-operator makes it easy to deploy KubeVirt into a cluster. The KubeVirt components, there are a lot of components that are complex configuration-wise. And to maintain upgradability and make it easy for people to deploy, we have this operator. The problem I ran into was that, inevitably I found some small tweaks and things that would need to be done to the various KubeVirt deployments that I really couldn't do because it was gated by this virt-operator. And like Fabian alluded to, if you find that you have to scale the resources for your individual deployments, maybe you have different priority classes or things you need to change about the way that the individual components are deployed, it becomes a little bit difficult if you're trying to do that through the virt-operator. So another thing I found was that virt-operator requires a lot of privileges. It needs to install webhooks, and it needs to install CRDs. And so if you're not the owner of the cluster, you may have trouble getting privileges for virt-operator to actually do the things it needs to do. So one of the solutions that I found to this was that you can actually run virt-operator in a mode where it will dump its install strategy to a config map. And when you do that, you can see everything that virt-operator was going to do, and you have all of the YAML, and you can tweak and then deploy that manually how you see fit. And I think there's room to improve this in the community going forward, and I hope to be able to work on that. I'm sure that I'm not the only one that has trouble using the virt-operator method of installation, and so I would like to see a more official and supported way to generate the KubeVirt deployment configuration. Another thing that I ran into was that KubeVirt by default will actually create a self-signed CA, and it deploys certificates for all of the components, which is really nice. It makes it easy, and it also does rotation often. And it uses config maps to deploy those certificates, well, actually secrets, I guess, and config maps, to deploy those certificates to all of the deployments in the daemon set. And so this comes into play when if you want to run, for example, VNC or console, in order for the authentication to happen from the KubeVirt API to the backend where the KubeVirt handler is, there's an authenticated mutual TLS tunnel created there for your VNC and for your console. And so one of the issues with that is that, some people don't like to run self-signed certs, or they'll have an official CA that they want to use. So because of this, I thought it would be good to add a configuration that allowed the customer to maintain their own certs. And the idea being that the virt-operator is usually creating these certificates and rotating them by using the secrets and config maps attached to all of the KubeVirt components. It should be possible for a user to write a controller that can reach out to the CA of their choosing and populate those same secrets and config maps for all of the KubeVirt components. And so I'm working on a design in the community to try to make that a permanent feature in KubeVirt so that customers can integrate with their own CAs. Another thing I ran into was if you try to use a custom kubelet root path, KubeVirt would actually break. And that was because it was actually maintaining the container disks in certain ways and doing mounts within the node. And it was looking for the disks in the wrong place. And so you would actually end up with VMs that wouldn't actually terminate. You'd have pods that would sit there forever waiting for the disk to be detached. And virt-handler didn't know where to find it. So that took some digging, but now with KubeVirt, there's a new flag you can add to the virt-handler to tell it where the kubelet root is. And that seemed to fix the problem. I also found an undocumented requirement for net raw. KubeVirt was assuming that net raw was a default capability of all of the pods and all of the containers in Kubernetes. And so if you run into a situation where your cluster has disabled net raw as a default capability, then you would run into problems running KubeVirt. And finally, I ran into a compatibility problem with KubeVirt and Containerd. Now, normally KubeVirt is compatible with Cryo, and it's mostly tested against Cryo. And theoretically, it should work with any container runtime. But we found that when running it with Containerd, there was a problem in parsing the C groups. And it was assuming that there weren't any colons, I think it was, in the actual C group path when it was trying to figure out where some of the container components were. And so that was patched, and now KubeVirt works with Containerd. So let's transition over to some use cases that I found have been helpful to me as an infrastructure engineer, and things that I've used KubeVirt for over the last few years. So again, many of these use cases are geared towards an infrastructure developer like myself through my own personal lens and things that I found KubeVirt useful for. The first one is a service that I think everybody who uses VMs would need, and that is template generation. So I found that I could use the KubeVirt device plugin in order to get access to dev KVM, and with that access, I could spin up containers that can run virt install, and I'll end up with VM templates. So I can create and build all of my VM templates out there inside Kubernetes. So the way this works is I've got a source repository and I can put Kickstart files in there. At the same time, I deploy a Jenkins deployment into Kubernetes. But then I configure Jenkins to have agents that are spun up as pods that have access to dev.kvm. So when Jenkins sees that my Kickstart files have changed, it goes and spins up an agent as a pod with dev.kvm, and then some scripting will run virt install, and it will go through, create the template. You'll end up with a qcow2 file, and then as the last step in the Jenkins pipeline, it can push that off to an artifact repository. And so you get the CI/CD pipeline of VM template generation all run in Kubernetes. And so I found that so far to be super useful and a great way to automate VM template generation. So another thing that I found KubeVirt useful for was to create my own personal development environments for Kubernetes itself. I didn't want to always rely on my laptop, and I didn't know who else might want to be using the same flows, same workflows that I am using, and I don't necessarily know if their systems support virtualization. And so I came up with this way of running a Kubernetes cluster inside of Kubernetes using a virtual machine. So the way this works is, if you imagine you have a Kubernetes cluster to target that is KubeVirt enabled, you can actually create a VM, and that VM can run Kubernetes. And then you can target that for all of your development purposes. This is super helpful if in cases where you don't have Minikube that can handle virtualization, or you want to create a consistent, repeatable process, or even for like CI/CD type use cases. If you need a Kubernetes cluster, not just for KubeVirt development, but for any sort of Kubernetes development, this would be a good way to automatically get a Kubernetes cluster that you can play with using Kubernetes itself. So the idea was that I created a VM template that using Cloud Init, I can actually trigger kubeadm to install Kubernetes inside of the virtual machine. And so you deploy this VM template, you use KubeVirt to deploy the VM in your cluster, and then you can target it and you can do all of your development on it. So specifically for KubeVirt development, this is the one piece where it's good to have node level access or be able to go out to that Kubernetes cluster and tweak one thing, and that is to enable nested virtualization on the nodes. Once you enable nested virtualization on those nodes, then your VMs can also host VMs, which means that these development Kubernetes clusters can now run KubeVirt, and you can run accelerated nested virtual machines inside of your custom development cluster. Another thing that I found really interesting is that I can actually deploy hypervisors with Kubernetes using KubeVirt VMs. And so, as I mentioned, I've been involved in virtual machine orchestration platforms for a number of years. And in order to develop on those platforms, you need environments that can be spun up easily and can be thrown away and rehashed and restarted. And so Kubernetes with KubeVirt allows me to do this. The general pattern is that you would create your control plane or all of your satellite services as pods. In my case, I set up the Cloud Stack Management Server as a pod, and I fronted that with a service and an ingress. And then you can deploy your hypervisors as virtual machines. And again, this is where the nested KVM really comes in handy. You can run virtual machines inside of those virtual hypervisors that you deploy. And I've done all sorts of interesting experiments with these. I've even run, VXLAN tunnels over the pod networking and done some more advanced networking tests and things like that with hypervisors. So I found it really helpful and interesting to be able to quickly get up hypervisors and get cloud environments and test new code and software and do different workflows and things like that in an automated way using Kubernetes. As far as other use cases that I could imagine people would want to do, there could be situations where people require different operating systems. They can't necessarily run inside the Linux kernel. They may have an appliance that is provided by a vendor and isn't something that they can run in a container. You could also use it as a stand-in for bare metal. If someone is requesting a bare metal host and they don't even really care about Kubernetes or containers, you can actually offer them a virtual machine instead. And so it really helps. It kind of goes back to that theme of consolidating all of your compute infrastructure onto a single data center compute platform. And KubeVirt really enables that. So I just wanted to finish off by talking about some tips that things that I've learned that I found useful as far as operating KubeVirt and using KubeVirt, and hopefully you'll find some of them useful too. The first one is regarding KubeVirt test suites. So if you look at the KubeVirt code base, there are actually tests, functional tests that are in the code base that you can actually target to a specific cluster. You can run it in a cluster. And you can actually set it up as a cron job inside the cluster, and that would give you like a continuous feed as to whether or not KubeVirt is working at any given moment, and give you statistics on, how well it's working. There's also a Prometheus endpoint in most of the KubeVirt services that you can monitor. Another good one is to deploy the Containerized Data Importer, CDI. That's kind of a separate project, still under the KubeVirt umbrella, and it's geared towards importing data into persistent volumes. It adds a custom resource definition to Kubernetes called DataVolume, and you can provide a URL or you can provide an S3 endpoint, and it will do the work of actually importing VM templates for use into your Kubernetes cluster. Another thing to consider is to beware of quotas and IP use with the virt-handler. Because virt-handler is a daemon set, and because it doesn't use host networking, every single node is another IP address that you may use up in your cluster. So if you have very large clusters and you're deploying virt-handler to every single node, that may be a significant number of IP addresses used up in your cluster. And also you have to scale your quota. If you have resource quotas for KubeVirt, you have to make sure you scale your resource quotas to match the size of your cluster so that you can deploy all of the virt-handlers that you need to. And the last one, I think I mentioned this several times, that the actual device plugin, the KVM device plugin that is provided by virt-handler can be used by itself. You can use it to create VM templates like I've shown, or you can use it for any other purpose that might require you to spin up a virtual machine manually. And I think that's all I had as far as tips. There's so many things about KubeVirt that I could add here. It has so many different features. There's GPU support and network virtual functions and different types of volumes and multiple networks. There are different tweaks you can do to the virtual hardware, and there's even more coming. So I think that speaks to the diversity of the use cases and the teams and groups that are finding KubeVirt interesting out there. And along those lines, I just want to thank the community for being open and providing feedback and answering questions and just being super helpful and welcoming in general. I also want to say, thanks again for the opportunity to speak to you as a group and to be able to share some of the things that I've learned. And I really hope that one day I'll be able to watch your presentation and you can tell me all of the things that you've learned and all of the features you've implemented in KubeVirt and the great experiences that you've had. And I hope one day I get to meet you all in person at a KubeCon in the future. But that's it for now, and I think we're going to go to a Q&A session. Thanks.